Manufacturers are constantly trying to reduce the environmental impacts of their vehicles. This is done by making incremental improvements to established technologies or experimenting with completely different forms of energy. At this point, most of the attention has been focused on battery-powered electric vehicles and to a lesser extent, hydrogen fuel cell vehicles. But these are still some time away from being the dominant technology. There could, however, be a third way, offered by another fossil fuel: natural gas. Natural gas is a hydrocarbon, and burning it produces carbon dioxide, but it also has comparatively low emissions and a high energy density. So has natural gas a part to play in the switch to greener transport? Let's explore. Natural gas, or methane, is the simplest hydrocarbon, consisting of one carbon atom and 4 hydrogen atoms. When discussing the role of gas in sustainable transport, a good first place to look would be the steam reforming of methane to produce hydrogen for vehicles using fuel cells. The process of steam reforming of methane is essentially a chemical reaction between water and methane to produce hydrogen gas and carbon dioxide, according to the following net equation. The water is heated to a steam, giving it the required energy for the reaction. This is the most common way of producing hydrogen today. However, from the point of view of sustainability, it has some issues. First of all, one byproduct of the reaction is carbon dioxide. Another problem is if we look again at our equation, we can see that for it to be balanced, we need 1 mole of methane to make 4 moles of hydrogen. This equates to 16 kg of methane to produce 8 kg of hydrogen. The energy density of natural gas is 13.9 kilowatts per kilogram and 33.3 for hydrogen. A quick calculation tells us that by exchanging 16 kg of methane for 8 kg of hydrogen, we get a 20% increase in energy. This seems like a waste of an energy source that has a lot of potential and is in limited supply. We also have to consider the fact that we need to use energy to produce the heat in the first place. And when we couple this with our waste CO2 problem, it's safe to say it's not really sustainable either. So producing hydrogen for methane is not the best way to make transport sustainable. What about instead we just use natural gas directly? This may seem a bit odd, but using natural gas as a fuel for transport is actually already pretty common. Natural gas powers more than 175,000 vehicles in the US alone and around 23 million vehicles worldwide. Given the very low density of methane gas in its standard form, it must either be compressed or liquefied in a tank in order to be useful as a mobile fuel. As it is the more popular option, we will limit our discussion to liquefied natural gas. LNG is methane gas that has been cooled to around -160 degrees Celsius to store it as a more dense liquid. So how does it compare to diesel on cost? Natural gas is traded on international markets in dollars per million British thermal units. Let's assume a price of $3 based on last year's average. However, there is extra costs like storing, cooling, and transportation. In one investigation, the final minimum cost was found to be $12 for a million BTUs. For argument's sake, let's say to get a truck from point A to point B, we need 1 million BTUs of energy. For truck A using LNG, this will cost $12. Diesel has 137,000 BTUs per gallon, so truck B needs 7.3 gallons of diesel for the same journey. Given the going rate of diesel of $3, we need $21.9 for the same energy. But the energy density of LNG is 85,000 BTUs per gallon, which is 60% the density of diesel. So while LNG is cheaper per unit, it will only go a bit over half as long as diesel. So there's a trade-off, and whether it makes sense to convert from one form to another will vary from customer to customer. But what about emissions? Methane has a much lower carbon content than diesel, and so produces less carbon dioxide. There's also the issue of particulates, a big problem with diesel engines. In one study, researchers built a small dual fuel engine and noted a 31% drop in NOx emissions when using 50-50 gas-diesel combination. So in terms of emissions, LNG certainly has an advantage, but with fuel economy this would change depending on the situation. In saying that, diesel engines have become more and more efficient, and as we saw earlier, a dual fuel system offers a big improvement on emissions. So, dual fuel systems certainly have the potential to pick up some of the slack in the near future, especially as air quality laws become more strict. But this will likely remain the preserve of heavier vehicles such as lorries and in shipping. Thanks for watching, more content every week, stay tuned.